All right, let's look at yesterday's domain and range paper real quick. Need to double check that you've done this correctly. If it's all real numbers, it's the negative infinity of positive infinity. So it's going left and right to infinity, low to high to infinity. Same thing here, left and right. So negative infinity, positive infinity. But the range, the high is at 4, but it goes low to negative infinity. We do the flip-flop, and I did not flip it. It should have been, no, I wouldn't flip it on that, sorry. I would only flip it if I have to actually flip it. Hold on. There we go. But I could just ignore that, and I would just rewrite as less than or equal to 4. I wouldn't flip it. I would only flip it if it has the number and then the y. So I cover that up, and then I do the flip-flop on this one. Okay, so make sure you have that completed and glued in the next page of your journal. And we are going to move on to functions as word problems and dealing with independent and dependent. So a function is a relation in which every member of the domain input value is paired with exactly one member of the range, your output. So to help us remember this, remember dachshund and ride. So write that out. Dachshund is domain, x values in for independent, or we could also look at as input values. Ride, range, y values, dependent values. The variable for the domain is also called the independent. Variable. The variable for the range is called the dependent. So independent means it doesn't rely on anything else. Dependent relies on something else. The independent causes change to the dependent. And the x value is independent. The y value is dependent. Because you're going to plug in a number for x, and then whatever comes out, your output, is going to be your y value. Which sometimes you don't have x and y. You have like s or h and c or t. You have different variables. So it's not only just x and y. So let's look at our first word problem. Suppose you're buying hot dogs for $2 each. For how much it would cost to buy the following number of hot dogs. So they've created a table. So hot dogs is our independent. This is independent. I'm just going to abbreviate it. Which is our x values, which in this case we could write it as h. It's not going to necessarily be x. So I'm going to say it's h for hot dogs. And then our cost depends on how many hot dogs you buy. So we're going to say our y is c for cost. So we can fill this out, right? One hot dog is $2. Yeah, because what do you do to the number of hot dogs to get to the total cost? Or what could I do to 1? 1 what 2? Times 2. What about 2? Times 2. 3. 4 times 2. Times 2. So 2, 4, 6, 8, 10. So for 10 hot dogs, it costs, what would it cost for 10 hot dogs? $20. Okay. Just an extra little one there. Okay, so our total cost, which we're going to use variable C, depends on how many hot dogs you buy. Hot dogs is going to be H. So we have two variables. Total cost is dependent. Hot dogs is independent. You can decide to buy one hot dog, no hot dogs, 100 hot dogs. You get to decide that. So that makes it where it's your independent. Can you buy, so our question is the situation discrete or continuous? So we've got to think back to what discrete and continuous mean. So look back at our notes. You got to remember what discrete. So discrete is indivisible. We count them. Has to be complete units. People, calculator, shirts, pets. Points are not connected. So that's discrete. Continuous is set of all numbers on an interval. It continues like 0 to 100. Speed, time, distance, gallons, height, and volume. So which one does it sound more like? Discrete, because what can we do with the number of hot dogs? We can literally count them. So if you can count them, it's discrete. Because remember, it's whole numbers. You can't go up to the counter and say, hey, I want half a hot dog. And they charge you $1. They're going to look at you like you're crazy. And they're going to tell you, you can buy one hot dog for $2. They're not going to let you buy half a hot dog. So whole hot dogs. So that's how we know. So then we need to come up with an equation using our variables. C is our cost, and H is our hot dogs. So the total cost is found by multiplying how many hot dogs you buy by 2. So C equals 2H. Because that's all we did, right? We looked at how many hot dogs we had. So 5 multiplied it by 2 to get the $10. You could write it either way, but usually in math, we want to put the number first, kind of like a coefficient, and then the variable second. Okay, so H is our independent variable because we can buy however many hot dogs we want. You can buy however many you want. You can buy 100 if you want. Yep. You can buy one for everybody at the game. Dependent means that the cost depends on how many you buy. So C, which is your total cost, that is dependent. It depends on how many hot dogs you buy. So we're going to find the domain and range of this situation. So it said, Mike decided to go to the store to buy hot dogs for tonight's dinner. He only brought $12 to the store with him. How many hot dogs can he buy and how much can he spend? So he only brought $12. So how many can he buy?
6.
Can he buy 5?
No. I mean, yeah.
Yeah, and he'd have leftover money. Can he buy 4?
Yes.
Can he buy 3?
Yes.
2?
Yes.
1?
Yes.
0?
No.
He can say, I decided not to do hot dogs. I'm going to do hamburgers instead. but he could just say, I don't want any. So he can buy up to 6. How much can he spend? Up to $12, because he could spend less. Because he has a total of $12. So our domain is H, number of hot dogs you buy. Remember when we did domain and range of discrete? It was like this. We've made a table already, so let's go there. How do we write our domain and range for discrete? What is this called? Just a list. We're just going to write the list. List of X's, list of Y's. So we're just going to make a list of how many hot dogs he can buy. 0, 1, 2, 3, 4, 5, and 6. You put the little curly brackets around it. So if it's discrete, you would just make a list. If it was continuous, we'd write it as that inequality. Okay, so then what's the range? How much can you spend? Let's see. We're going to have to make a list for this too. What matches with 0? How much money is 0 hot dogs? How much is 1? So see how these are matching? 2, $4. 6, 8, 10, and 12. So these are matched, which in this case, they did go up at the same, or go matching with the one right under it. So remember with discrete, you make a list. So write that out here. Make a list. If you can't have halves or quarters or anything like that, you make a list. Okay. Flip it over. We have one more example. It says, over the summer, you decide to open a lawn care business. You offer to mow your neighbor's grass for $10 per hour. So underline that. It's important. However, you explain to your neighbor that he or she will be charged a minimum of 1 hour and a maximum of 4 hours for the job. Total amount A for the number of hours H can be represented by the function A equals 10H. Is this function discrete or continuous? So we've got to think about, can we have parts or is it only wholes? So we're talking about hours. Can you charge them for an hour and a half? Yeah. Can you charge them for an hour, or let's say 2.5 hours, 2 hours, 3 hours, 3.5, 3.75? Yeah. Time is continuous. So that means that we are going to have a continuous relationship. So it's dealing with time, which is in hours, but you can charge for half an hour. Whenever you get your first job, you will clock in and clock out, and they pay you by the hour. And they will pay you for parts of an hour. They could pay you for 5.2 hours. They'll just multiply that time times however much you get paid. Some jobs, like if you have to actually make a sign-in sheet instead of a time clock automatically adds it up. But if you have a sign-in sheet, my first job, I was a lifeguard, and I had a sign-in sheet. I had to fill it out. I would say I was there from 12 p.m. to 7:30 p.m. So they only paid me by every 15, 30, 45, or whole hours.
Or it'd be like that.
Yeah.
Like a summer job as a teenager.
It was a lot of fun. So in order to do our domain, we can charge, what's the minimum amount they said they'll charge? Huh? $10 an hour.
1 hour maximum.
Yep. So it's between X, or what variable are we using for this? H, yeah. So H equals hours. Follow along. So it's going to be H is between 1 and 4. So whenever you have continuous data, you're writing it as an inequality because you can charge anywhere between 1 and 4. So it says a minimum. So that means I'm going to use less than or equal to, and a maximum of 4 hours. So this means that work any time between 1 and 4 hours. So meaning you can do 3.5 hours and get paid for that, or 3.75 hours. That'd be 3 hours and 45 minutes. So you just need to convert the minutes to a decimal of hours. Our range, what variable does it say our range is going to be? A, total amount. A, total amount. So we need to match up the 1 with a value. So for 1 hour, how much is it going to be? $10, because we have this right there. So $10 is, so A is between $10, and what's the maximum amount that he's going to charge? 40, because 4 times the $10 per hour is 40. So less than or equal to, less than or equal to. Those are your domain and ranges. So the important thing here is that continuous is written as an inequality.
Will always be less than or equal to.
Mm-hmm. The reason we use less than or less than equal to, because we write it in order from least to greatest. Kind of like our other ones we wrote from least to greatest. In least to greatest order. Okay, so the way we're going to put this in our journal is, it goes in this next page. You can just fold it. Make sure that you don't cut off anything whenever you fold this. So just fold it so that, see how this side doesn't have anything on it?
Hey Riley, can you pass the book?
Just fold it so that you're not going to glue on any of the stuff you wrote on. It's going to look like this. And then whenever I open it up, I can see the inside. And update your page numbers. And then I'm going to show you what your assignment is. So let's look at your assignment now. So there are 18 cards. You're going to do domain and range for these. And you're also going to decide if it's continuous or discrete, or if it's a function or not a function. So see how these all have numbers? So number 1, you're going to get a sort letter here for its domain and range. You're also going to put number 1 in discrete or continuous, and number 1 as a function or not a function. So there are, well, if we just look at number 1, is this continuous or discrete? Continuous. So we're going to put a number 1 here. Put them in order from least to greatest. So go through the cards and decide it's continuous or discrete. Is number 1 a function or not a function? Function. So we're going to put it over here. And then next thing you'll do is do domain and range. So what I would go through and do is all discrete and continuous function or not first. And then come back and do your domain and range. Do your domain and range here. I want you to write it here, and then you can look at this to see if it's on here. If it is, then write the letter on here. If it's not, then you did something wrong. So this is kind of your answer bank to make sure that you did it correctly. So you can go back and check it if it's not on here. Yeah, you can cut it out and glue it on there if you'd like to do that instead. It's up to you. But then at the very end, you put the sort letter. So let's say number 1 was, I don't know what it is. I'm not going to give you the right answer. Let's say it was M, which it's not going to be because it's continuous. This is a discrete domain range. You would put your letter right here. So whenever I go to check your work, I can look here and see that you've done left, right, low, high. And then I can check this answer sheet. Okay. You're going to be given today and tomorrow to work on it.
Wait, so how do you tell the picture if it's discrete?
So discrete, remember, look at your notes. How does a graph look for discrete? Discrete, points are not connected if it's a graph. And for discrete, they're written as ordered pairs, tables, mappings, or points on a graph. This is discrete, so look back at your notes. Continuous is a line that connects. It doesn't have to be straight. It could be any kind of line. These, right. No. Anytime it's a list like this would be discrete.
Continuous, discrete.
Yep.
So this is discrete?
So you can go ahead and do continuous and discrete, function or not a function. And then tomorrow we have a whole class. You can work on domain and range.